Hey guys, today we're going to be talking about 7.3, which is about angle-angle similarity, and the whole point of today's video is showing that triangles are similar. So going about that word similar, remember that similar figures have the same corresponding angles and the sides are proportional. Okay, so same corresponding angles and sides are proportional. That's what's going to make a similar figure. Now, we're talking about triangles right now, and our point is to show triangles are similar. So similar triangles are when two angles of the triangle are congruent, or the same, to two angles of another triangle. So as long as, if I have two triangles, okay, to show that they're similar, they both have to share at least two angles that are the same. This is where the theorem angle-angle similarity comes into play. Postulate's just another name for theorem. Okay, and this talks about how if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So if you look at our example right here, and you notice this box, okay, I'm going to use colored pencils to show that they're congruent, the angles are congruent. So looking at angle K matches up with angle Y because it shows that they're congruent with this identifier. Okay, angle J has two lines that represent that angle, and so does X. And then angle L matches up with angle Z. Okay, now it doesn't matter about the L and Z, just because these two are similar as well as these two. I just need two angles that are similar to each other to make them similar triangles. Okay, so if it looks like this, it says if angle K is the same as or congruent to angle Y, and angle J is congruent to X, so my yellows are the congruent and my greens are congruent, then triangle J, K, and L is the same or similar to triangle X, Y, and Z. Okay, so if I'm looking at this, how do you determine whether the triangles are similar? Remember, the solution of this would be that at least two of the angles are same on both triangles. So the solution is if the triangles are similar, then they have two pairs of angles that are congruent. So we have to determine if they are congruent by looking at what is identified. So I'm going to use my three colored pencils again. I notice right away that angle G and angle L are very similar because they're marked with a box. Okay, that box should tell you that those are 90 degrees, which means that they are right angles. So I know that those two are very similar, they're congruent. Now, on this first triangle, they give me angle H is 61 degrees, and on the second one, angle J is 29 degrees. So they're not the same. However, I have two other angles that I need to find before I determine if these angles are similar or not. So, step 2 is to find angle F to determine whether angle F is congruent to angle J. Well, based off of the other theorems, I know that all my angles have to add up to 180 degrees. So, angle G was 90 degrees, so I have 90 plus angle H is 61, and I need angle F to figure out what it is, so all my angles add up to 180 degrees. So now when I simplify this, I'm first going to add my like terms on the left side of my equation. So 90 plus 61 ends up being 151, plus my angle F is going to be 180. So now that I added these two sides up, I need to subtract that from 180 to figure out what's left over. So I'm going to subtract 151 from both sides, which means angle F is the only thing left over on the other side. And 180 minus 151 is 29 degrees. So angle F is 29 degrees. I'm going to go ahead and label that. I'm going to double check my work by plugging all of those in. So 61 plus 90 plus 29, my interior angles should add up to 180. And they do. So I know I did that correct. So now the whole point is to determine whether the triangles are similar. So this is 61 degrees, 90, 29. Now remember, now that I labeled this 29, 29 matches up with this angle because they gave me that angle as well. So I know if this is 90 degrees, this is 29 degrees, I know this has to be 61 degrees to make 180 interior angles, 180 degrees with interior angles. So I know that these triangles are similar because of this theorem stating that two angles that are congruent in one triangle with the same two angles in the other would make these triangles similar. So, okay, it says right here, by a similarity postulate, these triangles are similar. Okay, let's go ahead and work this bottom one. Try that one by yourself. Pause it for a second, and then we'll check our answers together. Okay, looking at these two triangles, I know that they share one angle that's similar. 70 degrees is in both of those triangles. I need to determine what the missing side is, a missing angle is, to determine if the triangles are similar. So I'm going to take this first one, this first triangle first, to find the missing angle. I know all the interior angles add up to 180, so I'm going to add 70 plus 58 plus, I'm going to call this angle A. And I know that all these angles add up to 180. When I add 70 and 58 together, I get 128. Now I have to subtract 128 from both sides. And I should get angle A is 52 degrees. Okay, so angle A is 52 degrees. Now I'm going to double check to make sure all these sides add up to 180. So 70 plus 58 plus 52 equals 180. So I know I have a triangle there. Now looking at these, this second triangle, I'm going to say this is angle B. So let's see if this corresponds. Well, right away, I don't even really have to do this because remember the theorem states that two angles in one triangle have to be congruent with two angles here. Well, these are my angles 52, 58, and 70. So far we have one that's similar. Okay, now 58 and 49 don't match up, and 52 and 49 don't match up. So this really shouldn't be similar, but we're going to double check our work. So for this problem, I have 70 plus 49 plus angle B equals 180. When I add 70 and 49 together, I get 119 plus angle B will equal 180. I now have to subtract 119 from both sides. And 180 minus 119 gives me that angle B is 61 degrees. Okay, so do both of these triangles share two angles that are the same? They share the 70. They don't share anything else. So these are not similar triangles. Okay, now let's flip it over on the back. Now here's the same thing. I want to determine, are these triangles similar here? Well, let's see. It looks like I only have one triangle, but there's another triangle inside. So if you look at this hint below, it says redraw the overlapping triangles as two separate triangles. Whenever you have an embedded figure within another one, I want to separate those two. So notice that they separated them right here for us. We want to figure out if they're similar or not. So far, if I use my colored pencils, it looks like 48 and 48 are similar. So they do share one. Now notice, this is triangle URV, and this is triangle SRV. What letter do they share? Okay, you should have said they share letter R. And that's the same angle for both of those triangles. It's the angle in the small one, and it's the same exact angle in the large one. So we don't have enough information to figure out what that angle measurement is, but I can tell you that the triangles are similar because angle U and angle S are similar and angle R's are similar. So yes, we're going to say angle U is the same thing as angle S. So there's one of our congruent angles. And then angle R is the same as angle R for the triangles too. So that's our second angle that's congruent. So I know that these angles are similar because they share those two congruent angles. Okay, now let's apply it to a real world problem. So it says, while playing tennis, Matt is 12 meters from the net. Here's Matt right here. He's 12 meters from the net, and the net is 0.9 meters high. Here's the net. He needs to hit the ball so that it just clears the net and lands 6 meters behind the base of the net. So we ultimately want the ball to land right here at point A. It asks, at what height should Matt hit the tennis ball? So we want to figure out how high from here to here he needs to hit that tennis ball so it clears the top of the net and lands at point A. So let's see. First of all, I see an embedded figure. I have two triangles, two right triangles to be exact, but they're embedded. So I'm going to pull those apart. So I'm going to take this small one first. I know it's a right angle. This is the net here, so I know they already labeled that 0.9. And the bottom of this right triangle from the net to where the ball is going to land is 6. The large right triangle, I'm given this base from where Matt is to where the ball is. They give me 6 and 12. So I need to add those two together to figure out the total distance from Matt to where the ball is. 6 plus 12 is 18. And again, the question's asking us, at what height should Matt hit the tennis ball? So here's Matt. We need to figure out this height right here, which corresponds with this part of this right triangle. I'm going to leave that as letter H. Okay, so I'm trying to figure out what the height Matt needs to hit the tennis ball at for it to clear over the net. So I noticed that these are similar triangles. I need to figure out exactly how they're similar. How are they proportional? So I'm going to set up a proportion here. I'm trying to figure out from 6 to 18 what happened. From 0.9 to what would happen. I'm trying to figure out, again, what's proportional. So in similar triangles, remember we stated that they have to have the corresponding angles and the sides are proportional. So I need to make sure from 0.9 to this number, it's proportional with the other sides of this triangle. So to figure this one out, corresponding side lengths have to be proportional. So with that, I'm going to set up a proportion. Now this is, remember what the term is, A to D over A to B is equal to D and E over B and C. Or you can just say long side over long side is equal to short side over short side for this instance. So I'm going to pick the long sides of my right triangles first. Or you can set up a WGU here. Okay, looking at the long sides of both of these triangles, I have 6 as the long side for this first one and 18 as the long side for the second one. I'm going to look at the short ones now. So going back to the first figure, I have 0.9 for the short side over H for the short side of the other triangle. So now that I set up my proportion, I need to simplify this and solve it. So when there's a proportion, I need to cross multiply first, or some of you might call it a butterfly. So when I cross multiply, I now have 6 times H on one side and 18 times 0.9 on the other side. When I multiply 18 times 0.9, I now have 16.2 on the right. Now I want to get h by itself because, again, that's what I'm solving for, which is the height that Matt must hit that tennis ball. So to get h by itself, I must divide by 6, which is the inverse operation of multiplication. I divide by 6 on both sides, and my answer should be 2.7. And if I relate it back to the word problem, okay, this should be 2.7 meters. Now we can double check this because remember that our sides must be proportional. So if I think about it, from 6 to 18, what did I have to do? I had to multiply by something. Okay, I multiplied by 3. So to make this side proportional with my other sides, I must multiply 0.9 times 3, and it should get 2.7, which is correct. So I know that these are similar because the side lengths are proportional. Okay, we're going to be doing some more practice with this today, so make sure that you have this filled out so you can refer back to it while we're working on the classwork. Have a great day.